geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. On observing light from three different stars, namely P, Q, and R, it was found that intensity of violet color is maximum in the spectrum of P. The intensity of green color is maximum in the spectrum of R, and the intensity of red color is maximum in the spectrum of Q. Okay? If Tp, Tq, and Tr are the respective absolute temperatures of P, Q, and R, then it can be concluded from the above observations that it is given that an observation light from the three different stars, namely P, Q, R, it is given that the violet color is maximum in the spectrum of P, and the intensity of green color is maximum in the spectrum of R, and the intensity of red color is maximum in the spectrum of Q, and the temperatures of the stars Tp, Tq, and Tr respectively for the stars PQR. Then the relation between the temperatures you are asked to decide. Okay, for that we should use the Wien's displacement law. As you know, Wien's displacement law is, listen carefully, Wien's displacement law is lambda m into t is equal to a constant. That constant is written as b. Okay, from this I can write that the lambda m is equal to b by t. Since b is constant, lambda m is inversely proportional to absolute temperature. Okay, and another important information is from the light spectrum from the light spectrum, as you know, lambda m for the p is less than lambda m for r is less than lambda m for q, right? Since lambda for red is more than lambda for green is more than lambda for violet, therefore I can say that the Tp is more than Tr is more than Tq. So that is the temperature relation. Tp is more than Tr is more than Tq. Therefore, option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. The two ends of metal rods are maintained at temperatures 100 degrees centigrade and 110 degrees centigrade. The rate of heat flow in the rod is found to be 4 joules per second. It is given that for the temperature range, right, 100 degrees centigrade and 110 degrees centigrade range, the heat transfer, right, that I can write del Q by delta Q by delta T equal to 4 joules per second given. Here 100 to 110 degrees centigrade. Therefore, I can say that temperature difference for this heat transfer equal to 110 minus 100 is equal to 10 degrees centigrade. Okay. If the ends are maintained at temperatures 200 degrees centigrade and 210 degrees centigrade, the rate of heat flow will be. For the other case, temperature range is given 200 degrees centigrade and 210 degrees centigrade. Then what will be the temperature difference? Temperature difference equal to 210 minus 200. equal to 10 degrees centigrade only. For the first case, for a 10 degrees centigrade temperature difference, heat transfer rate is given 4 joules per second. In the second case also, since the temperature difference is same, though both rods are maintaining high temperature, but temperature difference is causing for heat transfer. As long as the temperature difference is remaining same, the heat transfer rate remaining same. Right? Let me write that point. Since temperature difference is same, temperature difference is same for both cases. Therefore, the heat transfer rate remaining same, remaining same because the rate of heat transfer completely depending on temperature difference between the two rods. Anyhow, look at the option D. Option D is absolutely correct. That is 4 joules per second. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. Steam at 100 degrees centigrade is passed into 20 grams of water at 10 degrees centigrade. When water acquires a temperature of 80 degrees centigrade, the mass of water present will be. We are asked to take specific heat of water is 4 calories per gram centigrade and the latent heat of steam is 540 calories per gram. Okay, here mass of the water MW equal to 20 grams. Then initial temperature of water T1W equal to 10 degrees centigrade. And the water acquires a temperature. Final temperature of water is equal to 80 degrees centigrade. By the time temperature of the water is increasing from 10 degrees centigrade to 80 degrees centigrade, after condensation, by the time the steam is dumping the heat equal to latent heat, the steam is becoming liquid. Since the condensation of the steam is happening at constant temperature, that is 100 degrees centigrade. So once the condensation is completing, because of the further heat rejection to water, a part of the steam may be becoming liquid or liquid water, because here water is rising the temperature up to 80 degrees centigrade. That means after the steam is condensing at constant temperature, that is 100 degrees centigrade, again the temperature of that liquid is dropping to 80 degrees centigrade, that is the temperature of the water. So by connecting the energy balance equation between the steam and water, you can come to know what is the amount of water present in the system. So initially some water is there. Now let us decide what factor of steam is converted to water. The water available from the steam plus this water already available, that is 20 grams, is giving the total mass of the water present in the system at 80 degrees centigrade temperature of water and steam. Okay. For that, heat energy lost by the steam equal to heat energy gained by the water. So energy balance equation. Energy balance equation. Energy balance equation is heat lost by steam equal to heat gained by water. First, let me write the heat gained by the water. Heat gained by the water is mass of the water into specific heat of the water into final temperature of water minus initial temperature of water. It must be equal to the amount of latent heat transfer. Let ms be the mass of the steam. Mass of the steam into the mass of the steam into latent heat L plus mass of the steam, right? Mass of the steam into mass of the steam into specific heat of the mass of the steam is becoming mass of the water once the condensation is completing into initial temperature of water is 100 degrees centigrade. Initial temperature of the condensed liquid is 100 degrees centigrade. Final temperature of that condensed liquid is 80 degrees centigrade. 80 degrees centigrade. Now here let us write the mass of the steam outside into latent heat is how much given 540 plus specific heat is 1 and it is 20 is equal to mass of the water given 20 and S given. S is how much? 1. S is given 1 and T to W 80 minus 10. 80 minus 10. It is 20 into 20 into 70. Mass of the steam into 54 540 no? Should be very careful. 540 540 plus 20 560. Let me write clearly. Mass of the steam into 560 equal to 20 into 70. Right? Let us take another slide. Mass of the steam into 560 equal to 20 into 70. It is equal to 1400. 1400 equal to mass of the steam into 560. Therefore, mass of the steam equal to 1400 divided by 560. Simplify this for getting 2.5 grams. So this is the mass of the steam which is converted to water. This much amount of steam, this much amount of steam converted to water. Therefore, the total mass of the water, therefore, total mass of water at 80 degrees centigrade is equal to initial mass of the water plus mass of the water available from condensed steam, that is 2.5 grams. Initial mass of the water is given 20 plus 2.5, that is equal to 22.5 grams. That is the total mass of the water available at 80 degrees centigrade. 22.5 grams. Get the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. Certain quantity of water cools from 70 degrees centigrade to 60 degrees centigrade in the first 5 minutes and to 54 degrees centigrade in the next 5 minutes. The temperature of the surroundings is. It is given that in the case 1, initial temperature T1 equal to 70 degrees centigrade, final temperature T2 equal to 60 degrees centigrade. For the time period, let T equal to 5 minutes. Okay. In the next case, that is case 2, temperature is dropped to 54 degrees centigrade. In another 5 minutes means your initial temperature is correct 60 degrees centigrade and final temperature is equal to 54 degrees centigrade. For this also time period T equal to 5 minutes. Then you are asked to find the surrounding temperature. Let T be the surrounding temperature. That surrounding temperature is how much? Okay. For that, as we all know, the T1 minus T2 divided by 2 equal to K into T1 plus T2 by 2 minus surrounding temperature. For the first case, T1 is 70 minus 60 divided by this is the T, not 2. This is the small t. Small t, right? Small t is 5 minutes equal to K into 70 plus 60 divided by 2 minus surrounding temperature. Here it is 10 by 5 is equal to K into 130 divided by, right, 130 divided by 2, 65 minus surrounding temperature. Here it is 2 equal to K into 65 minus Ts. Ts means surrounding temperature, Ts. From this thermal conductivity K equal to 2 by 65 minus Ts. Okay, that is the thermal conductivity. This is for case 1. Case 1. Now let us take the case 2. Case 2, here I can write for the case 2, temperature range is 60, 54, 60 minus 54 divided by time period 5 equal to K into 60 plus 54 by 2 minus Ts. Here it is 6 by 5. K value you got it. K equal to 2 by 65 minus Ts. 2 by 65 minus Ts into 60 plus 54 114 divided by 2 57 minus Ts. Okay, from this I can write that cross multiplication 6 into 65 minus Ts equal to 10 into 57 minus Ts. 65 into 6, 30, 390. 390 minus 6 Ts equal to 570 minus 10 Ts. From this I can write that minus 6 Ts plus 10 Ts equal to 570 minus 390. 570 minus 390. 0, correct? 17, 8. Here it is 4, 1, 180. So 4 Ts equal to 180, then Ts equal to 180 by 4, 180 by 4, it is equal to 45, because 45 into 4, let me write it clearly, 44 into 5, 45 into 4, 180, correct, 180. Okay, so surrounding temperature is 45 degrees centigrade. Look at the options. Option A is absolutely correct. Understood clearly? It is, this is the third time we are discussing the almost similar problem. This is the 5-star problem. This kind of problem is more frequently repeating in the NEET. Okay?
Geobyte.